Hi, it's Mr. Crane again. I hope my Christmas music isn't bothering you. So this is Magnets Worksheet 3.2. It's for assignment 3.2. It is very simple. Most of us have interacted with magnets before. Um, and it should be easy to answer these without the use of a magnet. So I pulled this worksheet up here, and we're going to go through the four questions, or no, it's only three questions. So what do you notice about the interaction of a bar magnet that you were given? So even if you weren't given a bar magnet, maybe you have a magnet sitting on your refrigerator, or you have a speaker or something like that that you can use the magnet in, but you don't need a magnet. You've all interacted with magnets before. Um, this spoon, this spoon is made out of plastic. Does it attract to a magnet? Probably not. Probably not. What about this particular controller? Does it connect to a magnet? What about my cell phone? You see my cell phone? Does it connect to a magnet or does it get attracted to a magnet? Probably not. So you've interacted with things in nature or around you that interacts with a magnet or doesn't interact with a magnet. So what materials interact with magnets and how do they interact? So we have been studying about a new thing called dipoles. Dipoles, I'm going to put it right here. Dipoles are basically tiny little particles that have a plus and a minus alignment, and they fall themselves into or they align themselves with the field of magnetism. So one side's plus, one side's minus, and we know that opposites attract and likes repel. So what things interact with magnets? Things that usually have metal, but specifically iron. There are lots of elements on the periodic table that are metals that do not attract to magnets, such as zinc. So what things do not attract magnets? Again, plastic does not. What do all materials that interact with magnets have in common? So make sure you go and research dipoles. What happens when you bring a compass near a magnet? So if I bring a compass near a magnet, what do you think happens? Just so that I can give you a good idea, here's a simulator and it's listed in your assignments. Here's a magnet with a north and a south. When I bring a compass close to a magnet, what do you notice about that north and south arrow? So the south pole of the magnet is attracted to the north pole of this magnet. The south pole, the north pole of this compass is attracted to the south pole. And if you look, you can see all these little dipoles in here on this particular simulator. It's a PFET simulator for magnets and compasses. Once I start moving this around, you can see how each dipole aligns with this needle of the compass. All right. So as I bring this in close to it, my north is going to swing around and point towards my south. So you can answer it using the simulator. So do that, answer the questions for the magnet lesson, and that should help you. I'll be back in just a little bit to explain the next section.